In a previous video, we found this joint PDF with this funky sort of support where X and Y are depending on each other inside the support. Okay, so now in this video, I want to talk about how to find the expected value of X. Alright, so the expected value of X. So since this is an expected value of X and that doesn't involve Y, the first thing you're going to have to do is find the marginal distribution of X. Okay, so a lot of times we'll use this notation with a little subscript X to note that that's the marginal distribution, and then we'll use a little subscript XY to note that this is the joint distribution. Some people choose to use different letters like G or H. If you can keep that straight, then that's good. But I like the little subscript way of doing it. Okay, so this is going to be the marginal distribution of X. Okay, so to find the marginal distribution of X, what we want to do is basically project what we see here down to X. So we're going to integrate over Y, and that does the projection onto X. So we'll integrate f of x, y. Okay, so this is x, y, dy. We integrate over y. Now, if we're integrating over y, let's look, where does y, what are the bounds where this is not 0? Y should be between 0 and x. So it should be between 0 and x. Okay? So now let's go ahead and technically it's negative infinity to infinity, but this is 0 when y is not between 0 and x. So we can just write this like this. So we have 3/4 x minus y dy. I can pull that 3/4 outside. And now this is just calculus, okay? So x here is like a constant. So when I'm doing this integration, I should treat it like a constant. Okay, so actually let me undo that. So I'm going to have this x is a constant, so basically add a y there. And then this power is 1, so I need to make it a power of 2. And then I'm going to evaluate that from 0 to x. Okay, so this then, I'll have 3/4. When I plug in x, now remember I'm plugging in x for y because I just integrated with regards to y. So I'll have x times x, which is x squared, minus 1/2 x squared, minus, when I plug in 0, I'll get 0. Okay, so then this equals 3/4 times, this is 1/2 x squared. So this is 3/8 x squared. All right, so that's the marginal distribution of x. So let me go ahead and write that here. Okay, we found it was 3/8 x squared. Make that 8 a little neater. Now, what's the support? What can x be? Well, we've already integrated out y, so now x can be any number between 0 and 2. Okay, so we've already integrated out y, so now the support would be x is between 0 and 2, and then it's 0 otherwise. All right, so this is the marginal distribution of marginal distribution of x. All right, so now once I have this, now I can find the expected value of x, which is my goal. Okay, so now I can find the expected value of x. So now the expected value of x would then be the integral, technically it's negative infinity to infinity, of x times f of x dx. All right, this is the general definition for expected value of x. Okay, so now let's plug in what we have. X goes from 0 to 2. So I'll do my bounds from 0 to 2. Otherwise, it's 0. So from negative infinity to 0, 2 to infinity, the integral is just 0, so I don't need to write it here. X times the value of f of x, 3/8 x squared dx. Okay, so let me go ahead and scroll over. So now we just need to solve this. This is just calculus. So I'll go ahead and pull my 3/8 out front, and I have x cubed dx. So when I do this integral, I need to bring that power up to the fourth. And so I have 1/4 times 3/8, okay, evaluated from 0 to 2. Okay, so that is 332 times 4x to the fourth, evaluated from 0 to 2. 3/32, 2 to the fourth power minus 0. 2 to the fourth power is 16. So I get 3/32 times 16. These cancel, and that becomes a 2. So the expected value of x is 3/2.